So there is a YouTube which has been given. And of course, it will be two different liquids. So let me just mark it in white. What they are saying us here is one of these tube is subjected to a certain velocity. One of these tube is subjected to a certain velocity. So what's going to actually happen here is there is a disturbance which is taking place here, causing a low pressure. As we just thorough with hydrodynamics, when the velocity is high in the airstream, the pressure at that location would be lower, and when the velocity is the pressure is high, so the pressure is lower, the area is lower, and when the velocity is lower, the pressure is high. So I hope you are thorough with that. With that, based on this information only, we should start our exercise. So as I have said you that this is based on a particular past paper question. I think it was in 1990. We have tried that. In that, they were just asking you what will be the difference in liquid level. Okay? And it's filled with only one liquid. But unfortunately, we are having two liquids. So let me just explain you what will happen here. If it was one liquid, we are having our U tube. Let's say this is filled with one liquid. What's going to actually happen is they'll be at the same level since they are the same liquid. When this velocity starts, when this air stream starts to flow, as you know in hydrodynamics, when the velocity is greater, we'll be having a low pressure zone. Okay? Which you have learned in your streamline cases. When the velocity is high, the pressure is lower. So that case has to be applied here. Okay, that's why I was saying you that just try with that idea. It's almost the same essay. The format is the same, but to get the axis, you have to think different. So again, if I explain you that there is a airstream moving. So compared to this section, there is a velocity, which means there is low pressure, and this section has comparatively high pressure. So you know that you can't have these two systems together. Of course, from high to low, there will be a pressure flow. Okay, from high pressure to low pressure, there will be a flow. Causing this liquid to rise. So if you just look at after a while, due to this high pressure, low pressure system, this liquid level might have risen upward, and this liquid level would be drop. Okay. So this is the basic understanding you should have. Due to this system, from high to low, there will be a flow. Okay. So I think it's not taking right.
Sorry,
Okay.
sir.
So let me just start it. Sorry.
You said something before. I couldn't hear.
Sorry, I didn't get you. I think it's not lagging right. So I'll just start this. Okay. If you had just end out, just message me. So this was the case which is actually happening. From high to low, there was a pressure flow causing a water level difference. Okay. So this was done in our previous essay part. We were just trying to find this lane, sorry, the height. But unfortunately, now we are having two different liquids. But again, it's the same theory. So let's try it again. So let's see the question first. And the newcomer, I can't remember the name. I'll okay with the first parts. The high density liquid, the low density liquids. Because without that, you can't move for here. If you're okay with that, just fine, okay? Because you should figure out which liquid has the high density, low density. Now, for this question, you are requiring the density part. Okay. So let me just write here. So we are having two different liquids. So we are having two different liquids, A and B. As we have already found, the liquid A has a lower density than liquid B. The previous part I was discussing that. With the height levels, we just come into that conclusion. So liquid A's density was less than liquid B. Okay. So I hope you have got that. Okay. So with that, we can find the respective densities. The density of water is 1000. Density of water. So the higher density one is water, which is 1000. Can you say me what was the density we found here for liquid A? What was the density we found? The last class?
800 kilogram per meter.
Sorry? 800. 800?
Yeah.
Okay. So it is 800. Okay. So let's proceed the question. Again, the same idea. So I'm just going to explain it. Initially, we had a certain common interface level. We had oil up to a certain height, water up to a certain height, and this was my common interface level. From here, we were measuring the heights. The initial heights were Initial heights were 10 centimeters, and the height of image it was 8 centimeters. Okay. Now, what's actually going to happen is air is flowing through the tube where we are having water. It is flowing this way. if I just get you a 3D dimension, if these are my two tubes, air is flowing this way, okay? So there is no interruption for him. So just get that idea. There is no interruption for this tube. So what's going to eventually happen is, what would eventually happen is, due to this low velocity, there will be a low pressure zone. And as I have explained, there will be a high pressure zone. And let's say the velocity of the air as, now why I'm just finding this velocity? Because if you read the question, if an air stream having horizontal velocity Vp flows at the end of the tube liquid B, as shown in the figure, derive the relationship between velocity of air stream and the height of the liquid B from the common interface. So this is my common interface, just remember. This is before the airflow. Before airflow. Now what I'm doing is, as we know the basic theory, this won't remain the same. Because of this low pressure zone, this part start rising upward, and there will be a small drop in here. So there will be a drop in this section. So it's not furthermore 8, sorry, it's not furthermore 10. And there will be a rise in this section. There will be a rise in this section. And still we are having the airflow. Still we are having the airflow. So, let's say this was my common interface. And I'm going to find this height. Let's take it as H. Capital H. This height as capital H. Now see, these are not given in your question, but you must include them because they are asking a relationship between Vp and the height of the liquid. So just obtain them. Eventually you can subject in an equation because you're going to draw a graph right in the upcoming parts. So that's why I just obtain it as H. So if this is H, let's say this is somewhat L, a different parameter. So let's get into the equations. Now understand, this part of the system is not in contact with him. So only this section is disturbed with the air. So this part is free, right? So the atmosphere would be subjecting a certain pressure, as we know from our YouTube basic principles. The atmosphere is going to provide a pressure, which is our atmospheric pressure anyways. It's known as pi. Let's take it as that. See here, this part is not interrupted by the airflow. So atmospheric pressure was acting here. What can you say about the pressure in here? Let's say it is P. What can you say about this pressure? Is this pressure equal to atmospheric pressure, or less than that, or greater than that? Just get an idea?
Can you repeat the question, sir?
No, I was asking, in this part of the tube, there was no airflow, right? In here, we are having an airflow, but in here, we don't have an airflow. So we can have free atmospheric pressure acting here. So okay. Sorry for the coverage is okay. So that's fine today. Yeah, we are now see here. This is not interrupted by the airflow. In here we don't have an airflow, so that the atmospheric pressure is gonna act. Now I'm asking you, will the same atmospheric pressure acted here, or else will there be a different pressure? Let's come step by step.
Same atmospheric pressure.
Sorry?
Same.
Same. Any other answers? Okay. So just say your answers, okay? Let's see. Everything's fine. Because of course it's a confusing section. I'll just say you why it is. Because we are mixing hydrostat with hydrodynamics. So even if you're not going to get a structure like this, you might get an essay. I'll say you the reason. So for now, just say other answers.
Different.
If you are texting, just text to the this one. Okay, I'll just say this one. Because I have connected my phone in this. Okay, so just text to this one. Different. Yeah, fine. Other than that, yeah, different. Okay, fine. So the plane. So understand. Okay, I was just. That's why I was saying. Just consider this streamline flow. If we are having atmospheric pressure, we don't have the same atmospheric pressure here, right? Because there is a flow of air. Obviously, it will be smaller than that. Okay? You understand the reason, right? Because of this turbulence, or else this airflow, the pressure is here is lower. That's why this start increasing upward. Or else it would be remaining the same, right? Okay? So if you are fine, shall I move to the next one? Right?
Yes.
Okay. So understand. So let's get an expression for here later. So for now, get the idea. The pressure, these two equations are different, okay? Don't say they are the same. So I'm saying the pressure dissection as P. Just be free enough to include variables. If you try that essay, you will get the real idea, okay? It's filled up with variables and you might find the answer. So you get the theory that the pressures are different. Okay, we are having atmospheric pressure. The pressure here is P, let's say. So now let's start our basic equation. As we have studied YouTube, just try your basic equation. So I'm erasing these parts. So let's try our basic equation. If I write the equation for the pressures at these two locations, they are the same liquid. Sorry, it's the common interface. So the pressures at these two locations are same. P1, P2. P1 is equal to P2. Now let's write equation for P1 pressure and P2 pressure. So P1 pressure is equal to pi plus the length of the liquid is it is A, right? Liquid A is L. The density of liquid A is I'll just take with parameters rho A. Okay. I just write the YouTube equation H rho G. Atmospheric pressure is 5. Height of the liquid from the common interface is L. Density of the liquid is rho A into G. So this is my pressure at P1. Similarly, if I write for P2, pi plus the height of the liquid is H, density of the liquid is rho B times G. And we already know that the pressures are equal at this point. P1 is equal to P2. I already did that. So if I equate, right, sorry. Now see here, with the flow, I can also make mistakes. See here, I have taken the pressure as pi. Even though it's a YouTube question, the pressure is different, okay? It's P. So I'll just include P. Now when I equate both of them, P plus H rho Bg is equal to pi plus L rho Ag. Okay? So with your known information, you are able to write somewhat an equation. Okay? Now let's think about the other part. In the question, they are asking you the relationship between Vp and the height of the liquid. The relationship between Vp and the height of the liquid. Now we are having the height of the liquid. Yeah, it's fine. But unfortunately, in this expression, we don't have Vp. So now we have to come up with another solution. How can I include Vp onto here? Okay. So before I just start this, did anyone try this? The other equation? Or did you all get up to here? Did you all get up to here, or should I explain it again? Yeah, fine. And what about Shamla, Zafi? All right, that's fine. And Zafin, what about you? Fine. So okay. So let's get right. Fine. Let's try the other ones. So okay up to here, right? This equation, your YouTube one. So many stuff you might confuse. That's why I was saying. Fine. Okay, the next one. Now we are requiring an expression between velocity of air and the height. So I'll just explain you what's actually happening here. If I consider one side of the tube, the air is flowing. The air is keep on flowing. So let's see now. See here, the velocity at this point is Vp. The velocity at this point is Vp, and we have defined that the pressure is P. Okay. Now this air is flowing. It's keep on flowing. So somewhere at a point, this might come to rest, right? The air is flowing. Somewhere at a point, the velocity would be 0, right? At this point of the tube, the velocity is Vp, but the air is keep on flowing. So at somewhere point, let's say even after 2 kilometers, the velocity will become 0, right? Due to air resistance, those stuff. So if the velocity is 0, what can you say about the pressure at that point? In here it was Vp, and just a minute. My package is over Zoom package, so I think in a while it will cancel off. If so, use the same link, okay? So until that I explain. So the ice keep on flowing. The velocity is Vp at here. The pressure is P. When the velocity is zero, what is the pressure? Yeah, pressure will be greater than P. Yeah, really good. Just try to get an magnitude. We have already used in this expression